Good morning, students. How are you? Today again we will discuss what exercise 8.2 of mathematics class 9th. Question number 4, page number 150. It's given. Question number 4. What is this? ABCD is a trapezium. ABCD is a trapezium in which AB is parallel. This is a trapezium given. What's its name? A, B, C, D is a trapezium, and this and this is the line. What's its name? This name is E and its name is F. And what's given? First you can write given. In the given trapezium, AB is parallel to DC. AB is parallel to DC and BD is diagonal, and E is the midpoint of AB. E is the midpoint of AD. E is the midpoint of AD. A line through E parallel to AB intersecting BC at its meaning EF is parallel to what? AB. To prove now, to prove what you have to prove? Show that F is the midpoint of BC. F is the midpoint of BC. Understood? Let this is EF. G point you can take. Now proof. In triangle DAB, understood, EC is parallel to AB and E is the midpoint of AD. So by the converse of the midpoint theorem, G is also the midpoint of what? DP. Understood this? Now in triangle, in which triangle? BDC, GF is parallel to AB and AB is parallel to DC. Therefore GF is parallel to DC. Also G is the midpoint of DP. What? DP or not? So again, therefore by the converse of midpoint theorem, F is the midpoint of BC. hence truth. Understood? So what you can say? Again I want to repeat. What's given? A trapezium given. Which trapezium given? ABCD is a trapezium where AB is parallel to DC, and diagonal B and D, sorry, diagonal this BD joint, and E is the midpoint of what? AD is the midpoint of AD. A line drawn through E, that is the midpoint of AD. One line is drawn which pass through BC at F, and you have to prove F is also midpoint of BC, or you can say BF equal to FC. Given to prove, you can write. First take triangle. Which triangle? DAB is the midpoint and EZ is parallel to AB. So by the converse of what? Midpoint theorem. What saying? G is also the midpoint of DB. After that you can take triangle. Which triangle? BDC. Here again GF is parallel to AB, so GF is also parallel to DC, and G is the midpoint of what? G is the midpoint of DB, so F is also the midpoint of BC. By what? Again by the converse of what? Midpoint theorem. Now what? Question number 5. Question number 5. Exercise 8.2. In a parallelogram ABCD, what's given? You have given a parallelogram. What's the name of parallelogram? ABCD. What's the name of parallelogram? A, B, C, D is a parallelogram. E and F are the midpoint. E and F are the midpoint. This is point E. This is the midpoint of which side? This is the midpoint of this side. Understood? And F is the midpoint of side CD. This is the midpoint. Join this. Understood? Show that the line segment, which line segment? AF and EC trisect the diagonal BD. So this is your diagonal BD. This is your diagonal BD. You have to prove. What? This is name is P, and what's its name? Q. You have to prove. First write given. What's given? In a parallelogram. Which parallelogram? ABCD. E is the midpoint of AB. Understood? And F is the midpoint of DC. Understood? To prove, what's to prove? To prove is this PQ. What's doing? So that the line segment AFEC, this is what? FEC trisect the diagonal BD. It's meaning divide into 3 equal parts. It's meaning you have to prove DP equal to PQ is equal to QB. Understood? So what you can do? This is a proof. In triangle, which triangle? You can say BAP. BAP. Understood? E is the midpoint of what? AB. Understood? Is the midpoint of what? AB. So Q is also the midpoint of what? PB. What's its meaning? Therefore PQ is equal to QB. This is your first. Understood? Now in triangle, in which triangle? DQC, PF, sorry, F is the midpoint of this. Therefore P is also the midpoint of DQ by what? Converse of midpoint theorem. Therefore DP is equal to PQ. This is your second. Comparing first and second, we get dP is equal to PQ is equal to QB. Hence what? Result. Understood this? Now question number 6, sorry, not 3, 8.2. What saying? Show that the line segments joining the midpoint of the opposite side of a quadrilateral bisect each other. So you can say this is a quadrilateral. Which quadrilateral given? You can say A, B, C, D. Given you can write ABCD is a quadrilateral and PQR are the midpoints of the sides AB, BC, CD and DA respectively. Understood? And join these. Understood? Now what to prove? So to prove is what? Diagonal bisect each other. This you have to prove. Quadrilateral bisect each other. Midpoints of the opposite side of a quadrilateral bisect each other. This and this bisect. If we can prove it is a parallelogram, then we can say diagonal of a parallelogram are bisect each other. So what you can do, you can say in triangle DAC SR is equal to half of AC by midpoint theorem. Similarly, in triangle PAC PQ is half of AC and PQ is parallel to AC. Here is also what SR is parallel to AC. This is your first, this is your second. Understood? Comparing first and second, we get what you get. PQ is equal to SR and PQ is parallel to SR. Therefore, quadrilateral which PQRS is a parallelogram. Understood? We know that diagonal of a parallelogram bisect each other. So what you can say? What you can say? Hence result. So in it what beta? So this is P is the midpoint, Q is midpoint, R is midpoint, S is midpoint. So you can say this is half of it and this parallel to this. This is half of it and parallel to this. It's meaning this equal to this and this parallel to this. So PQRS become a parallelogram or quadrilateral whose one pair of opposite side is parallel and equal. So what's this? It's a parallelogram and diagonal of a parallelogram bisect each other. So you can do it till here. One more question left that I can tell in next lecture, then we can start next chapter. Try to solve these. If any problem, tell me. Thank you all of you.